Okay, welcome back to my calculus videos, example 3 of related rates. What we have in this situation is we have a police car driving south on a highway. We have a potentially speeding car driving east on a perpendicular highway. So we have a 90-degree intersection here. We're given some information. We're told that the police cruiser is zero point 0.6 miles north and driving south at 60 miles per hour. We're told that the perpetrator or the suspect is zero point 0.8 miles east. And we're told that the police officer's radar gun indicates a rate of change of 20 miles per hour of the distance between them. And the question is, how fast is the suspect driving? So again, I've already written down all the information and drawn the diagram. If you want to pause at this point and copy it down or just follow along, let's see what we know. Well, first of all, we need a relationship between x, y, and z. Pythagorean theorem is the opposite or the obvious one. X squared plus y squared equals z squared. Um, and we notice that that's actually the only equation we need. We're going to be looking for a derivative. So let me go ahead and circle in green the thing we want to find. And we know some derivatives and some distances. So let's find the derivative of this equation. And we're going to do this implicitly. So first of all, the x squared term, the derivative of x squared is 2x. Dx dt, remember chain rule says that we are taking the derivative of everything with respect to time, a separate derivative. The derivative of y squared is 2y dy dt, again chain rule. And the derivative of z squared is 2z dz dt. So let's see what we know. I'm going to circle in gold or blue the things we know. We know why because we're told it's zero point 0.6 miles north. So we know why. We know dy dt because we're told the cruiser is going 60 miles per hour headed south. We know x because we're told where the perpetrator is. We know dz dt because we're given that information. So we have two unknowns at this point. We have dx dt, which is what we want, and we have z. Now, let's pause and think about this for just a second. Oh, wait, if I know x and y, then I know z because I have a relationship here. So I know that I'll just stay in red. Z is equal to the square root of x squared plus y squared. X is 0.8, y is 0.6, 0.8 squared is 0.64. Remember, 8 times 8, 64, two decimal places. 0.6 squared is 0.36, 6 times 6, two decimal places. 0.64 plus 0.36 is 1. Square root of 1 is 1. We now know that z is 1 mile. We now know everything except for the speed of the suspect's car. So let's plug things in. 2 times x times dx dt, his speed, plus 2 times 0.6 times dy dt. Now we need to be a little bit careful. We've defined up as positive in our y direction, which means that the police officer's speed is actually negative 60, and that is equal to 2 times 1 times 20. So a little bit of math. I'm going to divide everything by 2 and make the 2 go away. 0.8 dx dt is 20 plus 0.6 times 60 is 36, which is 56. and therefore the x dt is 56 divided by 0.8. And if I remember correctly, 8 goes into 56 7 times, which means that this is 70 miles per hour. At the instance, interpretation now, at the instance that the police officer is 0.6 miles north and the perpetrator is 0.8 miles east, the perpetrator is going 70 miles per hour. Busted. He gets a speeding ticket. All right. Hope you learned something. Thanks for watching.